Warahmatullahi Wabarakatuh. Hello everyone, my name is Annisa Maiyada from class 6D and my student ID is 2210631050004. Today, I would like to present a material for our mid-semester examination in the course Mathematics Learning in English. The topic I will be discussing is powers or indices. I hope this presentation help us understand the concept better. Let's begin. First, we will discuss the definition of powers. Powers or indices is used when we want to multiply a number by itself several times. Here is an example of a power being read a to the power of b. In this term, a is called base or basis and b is called index or exponent. The word power sometimes also means the exponent alone rather than the result of an exponential or expression. In another definition, it can be said as power is the exponent that a variable is raised to. For example, the expression x to the power of 2 is read as x to the power of 2 or x squared, which means that the value of x is multiplied by itself as many times as the value of the power or exponent. Next, how to say powers? Here is the power from. When it look like this, we read it as x to the power of 2 or x squared. And this, we read it as x to the power of 3 or x cubed. And this, we read it as x to the power of n or x to the power nth power or x to the n or x to the n or x upper n or x raised by n. Okay, next. And this, we read it as x plus y all squared or bracket x plus y bracket close squared or x plus y in bracket squared. And this, we read it as 3 over 4 in bracket to the power of 5 or 3 over 4 in bracket to the 5th power. And this, we read it as 5 squared plus 8 to the power of 3. And this, we read it as 6 times a times b in bracket cube. Okay, next example. X to the power of 2 equals x times x. If the value of x is 5, then we can calculate x to the power of 2 like this. X to the power of 2 equals 5 to the power of 2 equals 5 times 5 equals 25. Likewise, we can calculate x to the power of 3 and x to the power of 4 like this. X to the power of 3 equals 5 to the power of 3 equals 5 times 5 times 5 equals 125. And this, x to the power of 4 equals 5 to the power of 4 equals 5 times 5 times 5 times 5 equals 625. Next, did you know? Notice that if you already know the value of 5 to the power of 2, which is 25, you can multiply it by 5 one more time to obtain the value of 5 to the power of 3. Important to remember, if a variable has no power or exponent, then it is assumed to be 1. For example, x to the power of 1 equals x. Also, any variable to the power of 0 equals 1. For example, x to the power of 0 equals 1. You can refer to exponential rules for a more detailed explanation of the rules you need to use when working with exponent. Next, law for powers for equal exponent. First, law for power. A times B in bracket to the power of n equals A to the power of n times B to the power of n. A product raised by an exponent is equal to product of factor raised by same exponent. And this A over B in bracket to the power of n equals A to the power of n over B to the power of n for equal basis. Second law for power. A to the power of m times A to the power of n equals A to the power of m plus n. The product of two powers with equal basis equals to the basis raised to the sum of the two exponents. When expressions with the same base are multiplied, the indices are added. How can we say this rule? This A to the power of m over A to the power of n equals A to the power of m minus n. When you divide two exponential expressions with the same base, you subtract the exponent. The base stays the same, and you subtract the exponent in the denominator from the exponent in the numerator. Third law for power. A to the power of m in bracket to the power of n equals A to the power of m times n. Exponentiating of powers equals to the basis raised to the product of the two exponents. Fourth law for power. A to the power of 0 equals 1 when A is not equal to 0. Any non-zero number raised to the power of 0 equals 1. Fifth law for power. A to the power of negative n equals 1 over A to the power of n when A is not equal to 0. A negative exponent means taking the reciprocal of the base raised to the positive exponent. Sixth law for power. A to the power of P over Q equals the key root of A to the power of P. A fractional exponent represents a root. The denominator is the root and the numerator is the power. Next, practice. Evaluating and simplifying expressions with powers. This is number 1 and this is number 2. Next answer. Number 1. 5 cubed plus 7 squared minus 2 to the power of 4 equals 158. And number 2, bracket 2 to the power of 5 over 4 squared, close bracket, square equals 4. Conclusion. Powers are used to show repeated multiplication of a number. The number being multiplied is called the base, and the exponent shows how many times it is multiplied. There are 6 important laws of powers, such as multiply powers, dividing powers, and using zero or negative exponent. These rules make it easier to simplify and solve algebraic expressions. And this is the reference I use. Okay, we have come to end. Thank you for watching. See you in the next video. Bye-bye. Wassalamualaikum warahmatullahi wabarakatuh.